Hey robot makers, hope you're having a good day so far. So do you have a home lab? You can see mine just behind me, just there. That's a whole bunch of Raspberry Pis. Do you want to give your home lab AI superpowers? Then this is the show for you. So let's dive straight in. My name is Kevin. Come with me as we build robots and projects, bring them to life with code, and have a whole load of fun along the way. Okay, I've only got a couple of slides for you before we get into the demo today. But yes, this is all about N8N. We're going to look at what this is and how it can give your home lab some superpowers. So what is N8N? It's a, what's the word? Portmanteau of node and automation, nodemation, which is N with 8 characters, and then N, which is N8N. It's also a no-code automation tool. I'm not sure about the no-code. I would just say it's a less code automation tool. We'll get into that in a minute anyway. So what is it? Yes, an open source workflow automation, kind of similar to Node-RED if you've ever used that, but it's probably a bit more powerful. It's a visual node-based editor, again a bit like Node-RED, and it's self-hosted. So you can use this instead of things like If This Then That or Zapier if you've used any of those services. So what it can do, it has over 400 plus apps and services. Just going to turn that down a bit there. You can automate repetitive tasks. You can make it do things for you. You can schedule workflows. You can process webhooks if you know what they are. You can transform and manipulate data very easily. You can make HTTP requests. That means you can call out to other web services, and you can run custom JavaScript or Python, which is quite cool. Strengths of it are it's free and open source. It's fully self-hosted, so you can run this on a virtual private network. No, a virtual hosted server, what they call VPS, virtual private server. Or you can just host it, as I have, and I will show you how to do today, on a bunch of Raspberry Pis, which is just behind me there. So this will run on like a Raspberry Pi 4 and up, but I would probably recommend, I've got some recommendations for you that I'll go into in a second. So there are no execution limits. It's not like you can run so many executions and then it stops. It's got custom code support, real active community around this, and it's fair code license as well. So it's not truly open source, I believe, but it's as close enough that it essentially doesn't matter to you. Some of the weaknesses are it does have a steeper learning curve. We'll get into some of that. I spent most of yesterday putting together these 3 demos I'm going to show you today. They get complex more that we go through them. So it does require some kind of server to host them, but it's really low power from a running perspective. And there's a fewer pre-built templates out there. There's a growing number of them, but it's still quite fresh. The user interface can seem a bit complex at first, and there are some documentation gaps, and you will need some technical knowledge to use this, but I guess it's aimed at people who just want to automate processes, so you've got to have kind of a background in that to start with. So it also has agentic AI capabilities. Agentic AI is all the buzz at the moment, vibe coding and so on. So you can use commercial AIs like ChatGPT, Gemini, Anthropic AI like Claude AI, or even better, you can host your own large language model using something like Ollama. I'll show you how to do that today, and we'll actually use that on all the demos as well today. And yes, quite acceptable to run this on a Raspberry Pi 5 or 500, or even better 500 plus. So I've got a 500 plus just above my head there. That white thing there is the 500 plus. So that one has 16 gigs of RAM. It has the NVMe drive in it, so it's really, really quick. So it's more than good enough to run some of these AI examples that we're going to look at a bit later on. You can see a bit of a peek there below what it will look like when we put these together. So shall we get into this? So if you like this video, you want me to make more videos about N8N or any of the other home lab stuff, definitely let me know in the comments. Let me know if you have a home lab yourself. So essentially a server that you play and learn on. Let me know if you have one of those in the comments. And if you've not subscribed to the channel, please subscribe. It means so much to me when people subscribe to the channel. It costs you absolutely nothing, and it helps grow the channel. So you can see there Martin that says he's got a home lab set up, but he's listening while being busily replacing thumbsticks on lad's Xbox controller for Hall Effect Unix. Awesome. I do go live as well every single Sunday, 7 o'clock GMT, so definitely check out if you can make it on the live stream, and we can have a bit of a chat at the end of the show. Okay, let's get over to our demo. So I've got some notes on the right hand side of my screen. I'm just going to pull these notes up, and all the code as well that we're going through today, you'll be able to follow this along in the show notes in the description. I'll put a link to where a lot of the code is and my write-up on the blog as well. Okay, so let's get over to a browser first of all. So I just wanted to give a shout out as well to Northwest Computer Museum. We visited them this afternoon. Real great day out. They've got loads of 80s, 70s, 80s and 90s computers, maybe a few early 2000s computers as well, games consoles, the lot. Really, really good setup. Really nice community of people there as well. And it's dead cheap to get in. Definitely worth a day out. If you're into retro computing, I just wanted to give them a shout out because they were really kind and nice today. Okay, so what I'm going to do right now, I'm going to go over to a terminal. So let me just load up a terminal. And what I'm going to do with my terminal, I'm going to, in fact, let's not use terminal, let me use the Raspberry Pi 500, I think. No, 500 we're going to go for. I'm going to show you how we can install N8N first of all. So what we need to do is we need some kind of Docker container setup for this. Now I've written one. You can download these. Again, the link to the file I'm going to show you now is in the show notes, so you can just go into the description and find that. So this is my clustered Pi. This is what I run on my home lab that's just behind me there. That's my clustered Pi. So all the Docker containers that I've configured, they live in here. So in here there's a folder that's called stacks and then N8N, and if we look in that folder there, we can see there's this Docker compose. If I do Docker compose up-D, D for detached. I need to do this. For some reason when I install this, I just need to run it as a super user. So let me just do that, up-D. And it's already downloaded all the container parts, so it's actually now running on there. We can ignore that about the kernel not spotting memory soft limits. That's fine. So if I now go over to this browser here that's just behind, this is actually running on this Raspberry Pi 500, not the 500 plus, the 500, which has 8 gigs of RAM, and localhost 5678 is where we want to go to. That's the port number. So if I click on reload, so this is now a fresh install of N8N. This is what it kind of looks like out of the box. So the first thing you need to do is enter some kind of email address. I'm just going to bang in my Gmail that I use for stuff like that, and then I'm just going to type in a password like so. You can even tick if you want to receive security and product updates. I'm going to give that one a miss this time. Save that there. And then it does ask you this one time, what's the way to describe yourself. So you could just say, I'm not using it for work. Where did you hear about it? Via YouTube by Kev's channel. You can also receive, if I just scroll down here, they'll give you this free license to get some extra features on there. I guess it's just to get hold of your email address potentially, but I've already got those. I'm going to skip that for now. We don't need those for what we're doing today. So this is what it looks like to be in N8N. What I'm also going to do is I'm going to flip over to a different machine. I just wanted to show you how easy it is to install this. And we're also going to be using today Ollama. So if I just go back over to my terminal on here, in fact, I think I've got a nicer terminal that we can go back to, that one there. If I go into my Ollama folder, I also have another Docker container, which if we bring that one up, will install Ollama as well. I don't think I've got that one set up on this machine, but I have got it set up on the Raspberry Pi 500. So we can actually go over to that Raspberry Pi 500, and it's the exact same process. You just do Docker compose up-D, and then you'll find that everything that you want is on there. So I'm hoping that this is going to connect. So here we go. If I go over to here, I'm just going to zoom in a little bit on this. I think it's Control Shift and Plus. There we go. Let's just load this up. And if I go into Clustered Pi, Stacks, and then Ollama, I think I've actually got Ollama running on this one. If I do Docker PS, a quick look down there, you can see I've got Ollama running locally on here. So that means two things. We get a nice user interface for Ollama if we want to use that, but it also means, more importantly, the back end of Ollama that loads the large language models can do so. So if we load up a browser on here, I think I've got a browser open. If I go to Ollama, in fact, I go to my local Ollama. I've got this running on port 3000. It's a bit tiny for you to see on there, I'm afraid. Let me see if I can zoom in a little bit. It doesn't, unfortunately, doesn't zoom in the URL there, but yeah, localhost 3000. That's just the port number I picked for this particular Docker container. If I make this full screen, maybe shrink that down a little bit. I think I've gone a bit too zoomed in there. Let's see if I can zoom back a little bit. There we go, that's probably good enough. This is what it normally looks like. So when you log into Ollama, the first thing you get is, looks very similar to ChatGPT. So you get how can I help you today, and some suggested things. There is a default model that will be at the top there, but when you very first install Ollama, you don't have any models installed. So I just want to very quickly show you how to get a model installed, and then we can move on with setting up N8N. So you go to admin, you go to settings, and then you go to models. And there is a link on here if you want to know what the models are called. But if you go to manage models on here, so I think they have a link to the Ollama models. Basically, if you go to ollama.com, click on models, you can see there the list of all the model names. So I think a good one to start with is either like Gemma 3 or Llama. Llama 3 is also a good one as well. I think we're on Llama 3.2 for this demonstration. So if I go back to the admin thing, I then just type in, for example, Llama 3.2. And I can click on download. I don't want to click on that now because it might interrupt with our live stream. I've got quite a poor internet connection generally. So if I click on that, that will then start pulling that model down. Once it's got to 100%, we can then use that in our chat. But again, this is just like the front end, but downloading the back end large language model is kind of essential for our next steps with N8N. Right, so now that I've shown you that, we can now go over to a regular browser window. Let me just go back over to here. And I've got, I'll show you the noodle planner in a minute. This is my N8N that's running on that Raspberry Pi 500 Plus. So the first demo that I want to create, I'm going to create this kind of from scratch, and I'm also going to have my comments open my other window so I can play along at the same time. There we go. So the first thing we're going to do, we're going to pull some data from, I think I've got a little temperature sensor, which is essentially an Arduino with just threw that out the thing there. Basically like a little Arduino with a DHT22 temperature and pressure sensor on it. So I want to get some readings off that. So the first thing I'm going to do is I'm going to pull in a trigger. So if I go over here, if I search for MQTT, you can see we've got MQTT trigger. And it's going to ask me for some details. I've actually set up my MQTT broker on here already. You can download one that's called Mosquito, which is free, and then just whatever IP that is, you just need to go to this little pencil and fill out the details. So for example, on mine, it's just MQTT. It's running on that port there, on that IP there, 192.168.1.152, and the standard port for MQTT is 1883. I've not got passwords and things set up on mine because it's just nice and open. So, and then we have this thing called topics. So topics are kind of the channel that we want to sort of listen on to. So I'm going to do /home/temp/loft. So I've got a temperature sensor in my loft. So if I now just click anywhere outside of there, I've now completed the first step in our process. So the next thing I want to do, I want to get the temperature and humidity settings from this. So I need an edit node. I'm just going to come over here, just type in edit. So edit fields, let's grab that one. And on here we can see that this is now kind of wired up like this little noodle thing here. And if I double click into there, I can then set things. So the first thing I want to do, let's just execute that previous node. It'll get some data once the temperature sensor, it fires every couple of seconds. So there we go, we've got a temperature and a humidity, and we've also got the topic. But what I want to do is pull this temperature and do something with it. So the first thing I'm going to do, I'm going to create a field. So I'm going to create a field, and I'm going to call this field temperature. And then we can drag this this message into our string value here, and that's bringing in this, I think they call this mustache, this kind of way of putting two squiggly brackets. It's got $JSON.message, but we actually want to do an extra piece on this. We want to do, we essentially want to do a JSON merge. So it's all capitals, parse. I'm going to parse this message, and then we're going to put that in brackets, and then we're going to do, excuse me, it's not that one, it's there. So JSON message dot temperature, and that will sort of tease out that that piece of information there. It'll look for that key and it'll pull out the value. You can see there underneath it sort of said 14.8 is the value, and that's the value of the temperature. We'll do the same again, so we can actually copy that. We can paste this into this other one down here. This one's going to be our humidity. So I just need to change that last bit to humidity. This is what I mean about being no code. It kind of is a bit of code. You can basically go online and talk to things like Claude or ChatGPT and get it to tell you these things if you don't know how to do them. So it's a lot easier nowadays to do this kind of stuff. So you can see there 71.8. So that looks good. So if I now click out of there, we've now got two parts to our flow. And then the last thing we want to do is I want to create a table where it's going to store all these values. So I'm going to save what I'm doing here. Let's just call this one live demo 1. Give that a save. And I'm just going to jump back to this little home here, which is kind of my home page. And this data tables thing, let's create a new data table. Let's call this one live temp, live_temp. We can give it some columns. If we go to columns, let's go for a temperature column. That can be a string, that's fine. Let's add another one, which is humidity. Humidity. There we go, add that column. We could add also extra ones like the location where this is coming from and so on, but for now this is fine. So I just wanted to create that data table that's called live temp, give it some columns. We can now go back to our live demo and we can pull in another node, which is a table. So let's just call this one table, data table. That's the one we want. Now you can either search for it by clicking this plus up here, or you can just click the plus at the end. It does the same kind of thing. So data table, there we go. We can bring that one in, and we want to insert a row. That's the action we want to do. So on here it says, what data table do you want to insert the row? It's the one that we call live temp, and then we can then map from, if we execute that previous node, it'll pull in those two fields that we split out. So we've got temperature, humidity. So we can drag that temperature one down into this temperature column that we created and drag that humidity into that humidity as well. And you can see it fills out the code for us. So in that example, it is true no code. We just dragged and dropped. Okay, so now that we've got this workflow, let's give that a save. Always remember to save. We can execute this workflow. So if I click on this, you'll see it's going to wait for the temperature to come through. It's going to split out those two values, and then it's going to insert a row on our data table. So we can go back to that data table. Let's click on that there. Let's have a look in our live temps. And there you go. We've got one when it very first ran. We can get rid of that particular row because it hasn't got any useful information in it. And you can see there that the humidity was 71.8 and the temperature is 14.8. Now that's great if you only want to run it one thing at a time. So currently this is just waiting for this trigger. If we click on inactive and make this now active, this is now going to run every single time that trigger fires. So if we let that run for a couple of seconds, we'll probably find that our table starts to get more and more rows in it. Sorry, if I go back to home and then into our data tables, then into our live temps, you can see there it's now firing you can probably see here, every 5 seconds it gets a new reading. So that's how often the temperature sensor is just firing out a new reading. So that's pretty cool. So that's a local table, just using local storage on this Raspberry Pi. So you've got tons of space on there if you've got a nice NVMe drive. You can see there it's got even more now. So it's not live updating, but we can see there we get more and more readings. It's fluctuated a little bit. It's gone down there and then back up there. So that's interesting just to see it's not spitting out the same number all the time. So that's our very first example. That's a very simple example of just kind of getting to know N8N. So if I click back on the home, let's go back into our live demo for a second. And some other things that might be worth looking at. We've got this little window here we can shrink and we can grow, and this is kind of like a debug window. Sometimes things will show up down there. So if we click on, I don't know if we click on that one there, do we see anything? No, we don't. So when we click in here, we have kind of the left side of the previous node, the node we're working on, and what the output node is. Now, when you're testing nodes, often you want to execute that step. You want something to happen, but rather than have to keep running this, you can pin the data. So if I pin this data here with this little pin, it'll keep those readings. So then when we go to the next one, we've already got those waiting for us. We don't have to wait for it to populate that for us, and that makes it easy when you're sort of dragging and dropping and things like that. So you can see some of the other things we've got in here. We've got parameters, we've got settings. There's nothing really that we need to note in here. We can execute that step directly as well. So you can see it's split those two out in that particular example. And you could also see just off the very edge there, if we click on that, that's the next node in the workflow. And there we go, we can execute that one as well, and it'll pull in those values, put them into our table, and our table even does a created at and updated at column as well. Another thing we can look at on here is, so this is the schema. This is what it looks like where you can drag and drop the different fields. You can look at it as a sort of tabular view. So it looks like a regular table. We can sort data if there's lots of data and all that kind of stuff. You can even look at it as a JSON object as well. So that's JavaScript object notation. That's, if you've ever done any programming, that'll look very familiar to you, but it's just a structured way of showing key value pairs. There's the key and there is the value. You can do that on the output as well. So you can look at the schema, you can look at all the different parts of it, you can look at the table, you can look at the JSON that comes out, and it also very nicely does some colour highlighting of the different parts of the structure there. You can copy that if you need to do some cut and pasting into something else, so you can copy that to the clipboard. Now they do say on here, once you've finished setting this up, you shouldn't have the pin data. You should unpin it so that it can continue running. So I'm just going to click on the save there. And then we'll go on to the next one. This one I think is a really cool one. This is quite a big one and it might take us a bit of time to do. So let's create a new workflow. So this one is going to be a server health monitoring app. So we're going to create something that will monitor all our nodes on our home server, any websites that we've got running that we're about to build. We're going to take a list of all these from a Google Sheet. So that means we can dynamically add or remove things from that sheet without having to change this flow, and we can do that completely outside of this, which is quite cool. This workflow is then going to go through that list, find out the different servers, whether it's an IP address it needs to ping, or whether it's HTTP that it needs to just do a health check on. They're the two options I'm going to build out. We're then going to get the results of that. We're then going to write that back to a different sheet on this same Google Sheet. And then if there is a problem, if any of them are down, we're going to send an email using a Gmail account. So it's quite a complicated piece, but this is really, really neat. So the first thing we're going to do, we're going to have a manual trigger. We're also going to have a schedule. So we're going to have a monitor schedule. So if I type in schedule, I have a schedule trigger. Oops. Let's just have that one side by side. Now, when you're building these out, you will find that the screen can sometimes get a bit cluttered. But over here, we've got this tidy up button, and this will sort of neatly arrange things. We can also zoom in. We can zoom out. You've got this thing over here as well. The more that you have, you'll see, like, as you're moving around the screen, you get that little mini view down here as well, which is quite useful. We'll also have a manual webhook as well. So let's just grab webhook. Let's grab that one as well. I'm not going to fill out that just now. I'm just going to put that one down there. And we're going to have a read from a Google Sheet. So if I click on here, I type in Google Sheets. And what we want to do is we want to read. We want to get rows from the sheet. Now, I've set up the credentials. I can't really show you this live, unfortunately, because it would sort of show you some secrets, some naughty people that could take those and destroy all my documents. But essentially, I've gone in here, I've created a connection to my Gmail account, and it does give you step-by-step instructions on how to do this. So if I go to here and I create new credentials, it always gives you like a how to fill out this information. So Open Docs will do exactly that. It always has like once it's authorize it, where does it need to send back to? So there's always like a redirect URL, and you'll get a client ID and a secret as well. So let's just close that there. So I'm just going to use my my Google Sheets one that I've already set up. which means if I double click in there again, sorry, we can then select which sheet that we want to actually use in here. So let's do that. We can have a look on here. I've got a sheet that I've set up that's called servers. So if I go over here, I've got this servers sheet. So I've got a server name, a type of health check that I want to do. I've got the target IP address or URL. I've got the health endpoint if it's a URL, and then there's an alert email that we want to send it to. I've also got a tab on here for some unmonitored ones. I'm going to use that in a minute so I can easily cut and paste them to sort of show you this dynamically changing. And I've also got a log sheet as well, which is dynamically updated by the worksheet that the workflow that we're going to create to show you the health of all the things that are on there. So all that is nice and healthy at the moment. So this is the structure that we're going to use. We're going to this server name, type, target, health endpoint, and alert email. So they're the names of some of my servers, the names of some of my URLs I want to manage, and the health endpoints are just /health on there, and they just give like a 200 HTTP response if everything is good. So that's the sheet that we want to use, and the worksheet, and then within the workbook you can then pick a sheet that you want to read from. So sheet 1 is what we want to read from. So let me just double check that that looks correct. I think that's all good. So then the next step, we want to route by monitor type. So depending whether it's a ping or a HTTP request, we want to do two different things. So let's just pick on here. They call it a, I think it's a switch node. Let's grab that one. Yeah, that looks correct. So we want, if we go to, let's execute that previous one there. Let's go back to the schema so I can see the names of the things that we can drag and drop. So the first thing I want is the type. So if the first value is ping, so let's do, if it's a ping, then we want to do something. Otherwise, if it's a HTTP, so let's add in a second routing rule. So if this type here is equal to HTTP, then we want to do something else. We can even rename these. If we don't rename them, I think it just shows it as like 1 and 2. So let us let's execute this step. I was looking to see if we could pin that data there. So yeah, we've got 0 and 1. So that doesn't look very nice. Let's rename those outputs. So let's rename this one to ping, and let's rename the other one to HTTP. And let's just click over there, click on save. You can see now we've got ping from here, and we have HTTP from the bottom one. So there's 7 things that have got ping from the sheet, and there's 2 things which have HTTP. And if we look back on here, we have indeed got 7 things. It says count 7 down here, and we have 2 HTTP ones. So that connectivity is working nicely there. So next up, we want to then to actually do the ping. So for this one, we'll need to execute a command. So let's do execute command. This is going to run a real command on our machine. So the command is simply ping, and if we connect this one up, in fact, we can grab that data from the previous step. So we can say ping, and then we can drag that target IP address over here. So it says ping and then that target IP address, and then we can do -c and then 3, which means ping it 3 times. So let's execute that step and see what happens. We should get back some nice ping responses there. Don't worry about what the content of that is. We're going to have another node parse all that and say whether it's up or down, which is nice. So that's so if we execute this entire step, let's do this and see what happens. You can see we've got that little spinning thing, so each of the nodes that's active will run. Okay, so let's have a look at that. The other thing I noticed on here, I had this execute once. We don't want to execute once. We want it to execute for each time, for each row that we have. So let's turn that off. Let's save that and execute this again. And we should see that it actually runs 7 times. So if we do 3 pings, is it 3 seconds per item? It's going to take 21 seconds for that to execute. Okay, so the next thing we want to do, so there you go, we've got 7 items, everything ran successfully, got a little green tick there. We can click on that tidy up again if we want to organize this a little bit better. We can even drag in our other nodes into this as well if we want to. We've not set up that webhook. I'm not sure if it'll complain about that. No, it seems fine. Okay, so the other thing we want to have on here, we've got this execute command. We want the HTTP request, so let's create that one as well. That's going to be a HTTP request. Let's grab that one. Let's make sure that's in the right place. That needs to be, if we want to get rid of that connection, we can just click on that and press delete, or we can click that little dustbin thing there. So if it's HTTP, we want to route to this one here. There we go. So what we're doing in this one, so this one we are going to do a get, and then what is the URL? The URL is going to be that health endpoint and the target. So if we grab target and we also grab the health endpoint, so both of them together should form the full URL, which it looks like it's doing there, which is good. I think what we need to do next, let's have a look. Usage headers, do we need anything on there? I think that's fine. You can specify headers, I think. Send headers. So I thought let's just do user agent. And this will just tell it, it'll tell my endpoint what it is that's pinging it. Health monitor /0.1. That'll do. Right, let's execute that. So we can see that one of them has come back as OK, which is good, healthy. Let's execute that again. Let's see if that's all good. Just checking everything looks correct on there. Yep, I think we're good to go to the next step. There we go. Right, so we now need to tidy these up a little bit. So we'll bring in a code block on this one. And this is going to be some JavaScript. Ugh, not a massive fan of JavaScript. So what I'm going to do, I think on this one I actually Googled how to do this. I essentially just put, well, didn't Google it. I put a request into Claude AI. So you can look through here. It says we've got an item, and it's all the items that have been input on the kind of left hand side, all the different rows. We've then got a results array. And then for each item in that items list that we have in, essentially it's been passed in, we're going to get the server name equals item JSON server name, the target, which is like the URL or IP address, and then the alert email, which is that alert email column. So it's just populating those. And then it says, let the status be equal to down, and let the response response time equals null, and the details equals nothing. And if the ping was successful, then we say item JSON standard out, and then it's basically looking for this. The output includes 0 packet loss or 0.0 packet loss. So each of those can be used because we've got this AND function. So it's that or that, not an AND, an OR. And then the status is up. So otherwise, if it doesn't include 100%, if it includes 100% packet loss, then it's definitely down. If it's degraded, so if the loss is less than 50, then it's essentially down as well. So what we will get when we execute this is either an up or a down, and it's saying both these are down currently, which is interesting on there. Oops, let me just save that. I just exited the wrong one there, so let me just go back into that. This is our live demo 2. Let's just rename that one live demo not 2. So I'm just going to double check that looks correct. Yep, that looks correct from a code perspective. And let's then do the same for our parsing the ping results. So I think I've just put that in the wrong one. That should be connected to there. And that one should be, there we go. I hooked it up to the wrong one. That's why it was saying that they were all down. Right, the other one we need is an if statement. Let's grab an if. Let's hook the if statement up to the correct node. So this one's going to be from here to here. And in our if node, what we're going to do is we're going to check whether it's equal to healthy or if it's not equal to healthy. So what we'll then do is grab Let's just execute our previous node so we get some values coming through there. This is where that pin data would have been useful, rather than having to run the entire thing, run all the pings, and it take 21 seconds. While it's doing that, we can actually type in here healthy. That's the value that I'm looking for. So to explain what's going on here, this website here that I've created that's called Noodle Planner, which is a really cool project planner piece of software. You can type in requirements. In fact, it comes before design, doesn't it? Design, build, test, deploy, for example. I can build out a little project plan with this software that I've created. You can even download that as an Excel. So this piece of software that I've created has a health endpoint. So if I do /health, we get this status is healthy and a bit of a timestamp. So all the websites that I build will have this health endpoint, and it's a way of just detecting whether everything's good or not. So we want to build that into our node. So let's have a look what's happening. Oh, it's waiting for that. I knew that would happen. Let's disconnect that and get rid of that webhook. We don't need that one for what we're doing. So let's just stop that with that stop button there, and let's execute this. And when it gets into this here, we can pin the data, I think, on one of these. Okay, just waiting for that to finish. Oh, there we go. So we've got some. There we go. Got some nodes that we can pull in. So it's the status that we want to check in the condition. So the condition is equal to healthy. That's what we're looking for. The other outcome is or the status, and then we can say does not is not equal to healthy. There we go. So if we execute this step, we can see that we get either healthy or unhealthy. Okay, so that looks good. They just look a bit strange to me. That's why I was just wondering what's going on there. But that's fine. We've got two that are coming out. And what we want to do next, we want to merge the results of these into a merge result. So let's go here and pull a merge. So this is going to merge all the data from the previous steps into a single kind of stream of data. And we simply just want to append on here. So we can just leave that so that everything goes into this. Just wondering why it's got the 2 there. Let's just check. So that one needs to go into, both of these need to go into, whether it's true or false, into the bottom input there. Oops. Right, now the next bit's quite cool. We need to write this back to our Google Sheet. So let's just find that Google Sheets. This time we want to insert a row. So let's go for append row in sheet. And again, this is the sheets one that we had before, the servers one, sorry, and then we're going to have this log. So we go back to our sheet up here. You can see we've got this logs tab, and this has got, I go to the very top of this, it's going quite long, it's a bit like a database this. We've got type, status, response times, details, timestamps, type check, and then host. So if we go back to our thing here, we can then look at what values do we want to send. So we can go over to our inputs from our merge node. We just need to run that last step so that we can pull those values across. Let's have a look. Can we pin the data on that previous one? There we go. So the data's come through. So we just type is going to go into type. Status is going to go into status. Response time into response time, details into details, timestamp into timestamp, check type into check type, and data. For host, what have I got on that one? Let's have a quick look on that. So you can jump back to previous nodes if you want to get a value that isn't on the you can go to previous but one node is what I'm trying to say. So you've got all these different nodes kind of in the workflow, and what we want to find is that read server list from the Google Sheet one. So get the rows, and we want that server name in our host there if it has a server name. Great. So let's, at least one value has values to send, has been added into values to send. Yep, we've added all those. And we just check that everything else is good on here. So we've got servers, we've got the append row. We have map each column manually, that's fine. Now let's just go out and save that, go back in, and we just execute that step. And it should pull all that data across and then put it into our log. So if we go to our log, we go right to the very bottom on there. It's now added in this extra block. Let's have a look at the time. 7:44. It might have even been that one there actually. 7:45, because it's 7:46 now. Looking at the time at the top of the thing there. So that data was written by this new node that we've created. Cool. So that's good. If we just want to output everything into a sheet, we could just leave it there. But what would be really cool is, depending if we get any answers where the server's down, we want to alert our operator that there's a problem that needs dealing with. So let's go back to that root, that switch thing there. And what we're going to do is going to say if the status is down, sorry, is up, then everything's fine. Otherwise, if it's down, we want to send an email. So the routing rule is if status is equal to up, and we need to make sure it's the right capitalization. So you can see when I drag that status there, it says up in uppercase. So we do need to make sure we match that. And then let's have another routing rule, which is the same column was equal to down. And again, we can rename these outputs. So this one is up and this one is down. And that just renames that little output. So that looks good. See if there's anything else we needed to do on there. That looks good to me. I think I did have an option on here which was send data to all matching outputs and have that ticked. Let's just do that as well. Right. So if any of these are down, we want to send an email. So let's format. So this is a format text. I think maybe this is a code one. Sorry, let's just drag the code one out. So this is going to be some more JavaScript. Yuck. Let's make sure I've got that plugged into the right one. So it's only if it's down that we want to send the email. And I'm just going to grab the code that I've created previously on this one, and I'll just talk you through what's in there as well. So we're grabbing all the items that are being passed into this node. We've got this grouped thing as well. So for each item in item, we're going to look for this alert email, which is just like my email address. Otherwise, we can default an email address if we want in there. If it's not grouped, then it's just going to equal nothing. Otherwise, if it's grouped, it's going to push that through as well. And then we have, this is the actual message, so the alert message here. So look at this, server health alert. So /n's just mean do like a new line. That's the convention there. So server health alert, and then server, and this is basically just going to count how many things are down. So server.length, servers are experiencing issues, and then for each server that's down, it's going to say the server name, the status, the target, or the IP address or the URL that's down, the name of the host if it has that, any of the details, the type of check that was done. So that was HTTP or ping, and then it's also going to do the timestamp as well. And then it says, please investigate this urgently, generated by N8N server health monitor. And then we just push all that data through to the next node. Okay, so that's that. We don't need anything for the up one. We're happy if everything's up. And then the very last step is we need to send an alert to a Gmail account. So let's just do Gmail and bring that node in as well. So this one is going to be send a message. So I've got my Gmail account set up again. similar to the method that we did for doing the Google Sheets. You just have to create a connection between your Gmail account and N8N. So this one is going to be a message. We're going to send it. Who's it going to be to? So on this one, I'll just put my email address in there. The subject can be whatever we have for the subject. Let's just execute our previous node. It's complaining that there's a step missing from that previous node. Let's just go and sort that one out. Let's just run the workflow. So it's saying that there's an issue in our workflow. Let me just have a quick look through where that will be. Let's pull up our debug window. Let's see what the issue is. What I find the best way with this is just to disconnect things and see, does it run up to that point where you have the connection broken? So on that one, yes, it looks like that's going to be fine. So it looks like the bug is in this code JavaScript 1. So let me have a quick look through and see if there's anything I've missed on that step there. So run once for all items, that's correct. That's fine. Let's go into here. So, do I need to select my Gmail account? Maybe that's what I hadn't done. So the subject is going to be... So why is it having a problem there? There's a problem executing the workflow. Because I need that to drag in the columns from there. So let's go to here. You can press this little play button at the top here, and that should execute that particular node. What we might need to do is pin the data from one of these when it's finished outputting that, so that we don't need to keep running it and wasting 21 seconds each time. So let's pin that data there, that's fine. We can do the same on here as well. Get that one, pin the data on there. Now let's go to here. Let's run this one. Let's go back into here. Still saying there's an issue. I'm not sure what's going on there. Come on, Kevin, what's going on there? Why is that not one working? So we've got Gmail account, we've got message, we have send. Let's change the type to text on there. The message is going to be, so these are basically going to be equal to, let's just type it in manually. So $JSON dot subject, and then the other one is going to be, the actual message itself is going to be $JSON dot message. It'd be nice if we could just drag and drop them across there. So let's see if we can execute that step there. So it says it executed successfully, so I'm not sure why it was being fussy there. Let's save that. So what I'm going to do, I'm just going to open my Gmail and see if I've actually got that message come through. If everything was up, we won't get any messages. If there's any that are down, we will get messages. So I think currently I'm not going to get any emails coming through because there is no data. That's probably why we had that issue setting this up in the first place. So let's go back over here, and I'm going to add in, let's add in a node that's, these two nodes are currently not working properly. So I'm going to add them to my sheet here. I'm also going to add in another one in a second, but let's just add those in and then go back to our entire workflow, execute this, and we should get a couple of items that are down. So interestingly, it says oh, you can't pin data. That's the other thing as well. Let's just unpin that data. It does complain about this quite a bit. Let's just unpin that data and then run the workflow again. And this is what, when I was saying at the very beginning about being a bit of a learning curve, it is a bit finicky. There is things you need to learn about this. It might be low code, but there's definitely code involved in it. So you can see there we're doing our pings. I think it's already done the HTTP requests. They look like they've come through. And we can see, if we go back to that tidy, save that, and let's just minimize that. So there's a problem in the execute command. What's the problem there then? Fail to ping. Right. So if that happens, we want to continue when we get an error. So if it can't ping one of the servers is down, it's not going to return a ping request. So we want it to continue on there. So let's save that and rerun it. And what should happen now is, if it can't ping any of those servers, the two that I know are offline, it should carry on and report those as errors through that that chain of command. This is one of the more complicated things we'll build today. The third one is actually, from a node perspective, quite simple, but a lot more powerful than this. This is kind of like a traditional workflow, automation workflow. So each thing is a discrete set of steps. They do something and they carry on. There's not very much intelligence going on. It's just kind of simple if statements to check the status of things. Okay, so that's it's nearly finished now. It's pinging of all those different things. It's done its HTTP requests. It says now there's a problem sending that email, so let's have a look what that is. So now that we've got these on here, we can actually drag and drop that subject, for example, can drop onto there. Let's just get rid of that, drag that subject. Let's do the same with the message. Let's drag that message onto there, and we can execute that step as well. There we go. So it's now sent an email. So I'll wait that to come through, and then I shall share my screen and show you that email coming through. Let's wait for that to come through. Just take a couple of seconds. Let's just go over to Gmail. And there we go. We've got the servers down. So it says on here, server health alert. This is what we actually typed into that node before. 2 servers are experiencing issues. So node 1 and node 3 have got problems. And you can see they're generated by N8N server health monitor, and it was also automated with N8N. So we can get rid of that very bottom one there. If we go back into our node, into our email node, we can say display note on, well, it's not that one, sorry. Add option, append N8N attribution, we can turn that off. So if we do that, we send that again, it would send it without that very bottom bit on there. If we look into that JavaScript as well, we've said generated by N8N, but I could say generated by Kevs, whatever. If I wanted to change that, we'd have to change that in the previous step because this is being passed through as the message. So we could change all that if we want to as well. So there we go. That is our full end-to-end flow built live, and you could see that that actually worked. So if we now go back to our sheet, we can get rid of those ones that we know are down. Take that off our because I'll keep getting notifications about that. If we want to make this live, we can just tick the active, and that means that this will run however often we want this to run. So we could have this run, for example, as a scheduled, so these, they've got scheduled trigger. We could say run this every 30 minutes, whatever you want it to be. And then it will fire that off and start running it every 30 minutes. If you don't want it to run, you can simply just click that active button. You can also do that from this here as well. So there's our live demo one. We could switch that off because I've actually got that running live as well in the background. Right, that's the second one. Let's do the very third demo. This one is a quicker one to actually put together, but I think this is a more powerful one. This is the AI one. Let me just bring this up on my other screen so I can follow my own instructions there. So we installed at the very beginning of the show Ollama, and we downloaded the Llama 3 large language model. So we can actually use this on here. So we can, let's just type in the word chat. So this is going to be a chat trigger. That's fine. And then next we want to have our AI agent. So if we just type in AI agent, let's bring this across. So that's what they look like, chat and the actual agent. The agent needs 3 things to work well. It needs to have a chat model. So you can plug in Claude AI, ChatGPT, or if you've got a Raspberry Pi 5, you can use Ollama and run that directly. We'll try this on the Raspberry Pi 500, which this is running on, and we'll also try it running on this Mac that I'm broadcasting from. The Mac is obviously going to be a little bit quicker, but I'll show you just to see that the Raspberry Pi does work. Memory, We can use simple memory. We can say what's the context window length. This is just going to save the interactions, the actual text that you've typed in. It's going to save that. And we also need tools. So let's just tidy it up a little bit. So let's choose our chat model. This is going to be, you can see all the different ones we have available there. Lots and lots of different models, but we want the Ollama one. So let's type in Ollama chat model. So you need an account. So I've got either the Raspberry Pi or my MacBook. Let's do my MacBook first, just because it'll be quicker to demonstrate this, and then I can show you the speed on the Raspberry Pi as a kind of secondary one. You could also see on there, sorry, jumping around a bit quickly, the model that we're using is Llama 3.2, so it can ask Ollama what models have you got loaded, and we've got Llama 3.2 on there selected. So when we type in a chat window, it's going to go to the model, process whatever we've typed in. It's going to store what we've typed in its memory for reference for future. And then we need to plumb in some tools. So we could plug in the Gmail tool that we used earlier. So this one could be, so instead of sending, we can say get many messages. We could limit that if we want to, or we can just make the model decide that. You can simplify that, or you can let the model decide that as well. Let's let the model decide everything, to be honest. So that one is just going to get messages. We can include another tool. Let's grab another one, which is let's send an email. So it's the same kind of node, the Gmail tool, but instead of getting messages, it's this time I'm going to send a message. And who's it to? Well, that's going to be defined by the model. The subject and the message are all going to be defined by the model. And it makes it easy if we actually rename some of these. So let's just go in here and say this one is read email. Let's have that one as just send email. And let's add in some other nodes as well. So let's grab a calendar one. So this is another Gmail calendar. Is it called Google Calendar? So get availability. That sounds like a useful one. So I've connected up my Google Calendar. You can choose which calendar you want to pick from. Let's do family. And then the start time and the end time, it's specifying those there. I prefer it if the AI could pick those. I'm not sure whether we can allow that to happen on there, but that's fine for the tool. Let's just there we go. I think I picked the wrong one. I need the tool. So let's do Google. If I click on there instead, oops, Google Calendar tool. It needs to be the tool one. There we go. And that's why we've got now the option on there. We can pick family, or again we can let the model decide on that one. The operation on there might just be get, and this one can be check calendar. And that looks better. Right. Let's bin that one off there. And did we disconnect? Nope. And then finally, let's add one more tool in, which is weather. So Open Weather, they have a tool pre-configured on here. I've set up the API key for my free Open Weather app, weather map. And on here, what we want to do is, yeah, you can either get the weather, get the current 5-day forecast or whatever. Current weather's fine. Let's call this one get. Well, let's call it weather. There we go. The city name, we could let the model decide that, but I'm just going to type in Manchester, UK. Okay, so there are our tools. Let's just tidy that up. So now, if we want to chat, you can see down here there's a little button that says chat. If we pop that out, we can actually type in a request. So what the request could be, let me just bring up my notes to see if there's any good suggestions that I had on here. Right, before we do that, let's go into our chat agent, and we can specify the system prompt that we want to use. So prompt user message Is it that one, or is it the system prompt that I want to change? Sorry, I just can't remember where that one lives in there. So it must be in there. System message. Right, so this one, I'm going to just grab this this prompt. So depending on what you specify in your prompt, you can make these much better. So I'm going to grab that and show you what this looks like when this comes through. So here we go. So you are Kev's personal AI assistant with access to Gmail, Google Calendar, Open Weather Map. Your role is to help manage his schedule, communications, and daily workflow efficiently. Your capabilities. So we've told it what tools we have and what its responsibilities are. So email management, summarizing long email threads, calendar management, and so on. Communication style. Be concise and actionable. Key values efficiently, or Kev values efficiency, and so on. So you can see there we've now got this this system prompt that will be sent to the chat. So that's quite an important step there. Right. So let me start with can you read me emails and summarize the last 3. Okay, so when I run this now, you'll see there that the AI agent has contacted the large language model. It's fed it that system prompt that we had, and the system prompt is then going to figure out what it needs to do next. So which tools is it going to use? So it should go to the read email node, and it should start pulling back the emails we've got on there. So this is actually running on, if I bring up my activity monitor, I don't know if you can see that on screen. So we should see that the Ollama task is running on here. Doesn't seem to be taking up too much CPU, which is good to see. But yeah, Ollama is basically helping out on here, and you can see all the different steps on there. So it's read the email. It's now, so if I click on that step there, you can see that email that we looked at before, the server health alert. The simple memory has just stored the actual request that we've made on there, and that the chat is now summarizing all this. So you can see there the input is you are Kev's personal AI assistant, blah blah blah, and here's our output. So you can see on here either side, either on the chat window that we've just typed in there. So here's a summary of the last 3 emails in your inbox. Server health alert, an email from an unknown sender alerts you, and then we've got the product update, Arduino weather station. We've got meeting invitation, community engagement, and outreach. So they must be 3 emails that have come through there. And this has all run locally. So none of the AI that we've touched on here has actually gone out to a cloud service. This has all run the large language model live on my Mac. So we could change, if we wanted to, that large language model. So instead of running it on my MacBook, we could use the Raspberry Pi. So you can see there that IP address there is the Raspberry Pi 500 plus. So this one here, that's the IP address of this machine. We go to is it connection settings, wired connection. I think you can find the IP addresses in here. I've specified a static IP, but I think the 190 is its other IP address. We go to a window and just type in IPA. Scroll up to the top of there. We should find that the IP address of this, there we go, 190. So that's the IP address of this machine. So that's the large language model is now selected for this Raspberry Pi 500. If I do pin out, no, not that one. Let's go to Task Manager. In fact, we can probably see it in that H top. I just want to show you that it's got 16 gigs of RAM. You can just about make out there 16214. I'll type in H top, you might be able to see that a bit easier there. 15.8 gigs of memory available to all the apps. So the reason that that's useful, and we'll come back to this window in a second when we're actually running the model. Let's go back to here. Let's run that one there, that's fine. And let's type another chat. So let's just save that. Let's go to another chat and let's type in what is the weather like. So it should recognize that this is a request to use the weather tool. Now that's now running on our large language model. Let's go back to that Raspberry Pi 500 Plus and let's have a look at the CPU usage. You can see there that Ollama is maxing out on all 4 nodes 100%. Interestingly, it doesn't steal all the performance. Other processes can run in the background, but it's just using all the available capacity that is available to run the large language model. So it is a little bit slower than you would expect than the MacBook, but it's not unworkable. So some of these requests come back in 20 seconds, something like that. We can wait and see how well this does if you are willing to wait with me on this one. So let's go back to our workflow. Let's see what's happening. We can see the different steps there in the log. So it's been running for 54 seconds. We can see there the memory. It's typed in. We can see what it's previously grabbed. We can look at the request there, which again is you are Kev's personal assistant, and we've typed in what is the weather like. So it should then go to the weather tool. We should see that in the little log of things in a second, that it's gone to weather tool. It grabs the weather based on the location that I've told it to in that tool, which is Manchester. We could have made that AI defined, so we could say what's the weather like in San Francisco, and it would come back and tell us that as well. So we could modify that if we wish. There's no limit to how many of these tools that you add into the AI agent as well, so you can really build these out, but you can see how powerful this can be. And again, we've not used any cloud-based AI. This is all running locally and can run on a Raspberry Pi. So it's just a tiny bit slow is all I would say. But we could choose a more memory efficient model. So if we choose like DeepSeek, that's quite small to run on a Raspberry Pi. We can have a look and see how much memory actually that's using on the Pi itself. So it's only using 7 gigs of RAM. It's not using like massive amounts. It's not used all 16. And we'll see in a minute, this will drop down back down to like 1 or 2%. And that's when we know it's actually finished running that large language model task. So we can perhaps just have them side by side. We'll see once it's finished that. I'm sure when I did this test before, it didn't take that long. We've been running for 2 minutes, 36 seconds so far. That's why I ran it on the MacBook first. But I do want to give you a live demo of this and show you what this actually looks like. So have a think about what you would do if you were building out your own N8N workflow. We can have this running in the background. I could go to another node. I could create another workflow. It would carry on running as well. So there are so many nodes available. They break them down into these different areas. So there's AI-based nodes, like this AI agent, action in an app. So things like Telegram, Notion, basically any web-based software that's out there has an app available. You can transform data, convert data from one format to another. You've got the flows, so branching, merging, looping, and so on, if statements. We've got core, which is things like HTTP requests. There we go, we've got the weather result coming back now. And then human in the loop, wait for human approval before proceeding. You can even basically create forms and have somebody fill out a form, and then it'll run the workflow based on that form. So let's have a look what we've got there. So we've got the weather results coming through. So clouds, broken clouds, temperature feels like min-max temps, simple memory, and we've got the Ollama result coming back. So it's now parsing this through again, and it's going to come back with a nice little statement in a second to tell us what it's found from that weather request. But you think what's going on here, it's really dynamic, so it's not bound by automation rules that we've defined like we did in the second demo. This is all being powered by AI large language models. There we go. So we got the results back, and it took, let's have a see there, was it 4 minutes? 4 minutes and 33 seconds to process this workflow. So the current weather in Manchester is mostly cloudy, as it always is in Manchester. According to Open Weather Map AI API, the temperature is around 12 degrees. Let's see what my watch says. My watch says it's 11 degrees, so it's not far off, and it feels like 11.73 degrees Celsius, 13 degrees Fahrenheit. There's a moderate humidity, 89%, and the wind speed is approximately 1.54 miles per hour, 2.49 kilometers per hour from the northeast. So there we go. We could have that that summary sent to us as an email. If we put that in as a prompt, we could have had that return that. So you can see how this has possibilities. One of the workflows I've seen used quite commonly with the N8N is you have a large language model take in some data and then categorize the data. So which of these buckets does it best fit into? So say sentiment analysis, you could have it read all your emails and say, is this a marketing email? Is this a request for, YouTube collaboration? Is this a work-related email? Which project that you're working on at work is this to do with? You could have it classify, maybe label them. You could go back and get it to label the messages in Gmail or Outlook or whatever email tool that you're using. You can even have it check your calendar and see, when are you available next week? When would be a good time to meet with Martin or whoever you want to meet with? And it'll go off and do those things for you. So very, very intelligent. Doesn't require very much plumbing together. And if you have a machine that's got enough grunt to run these large language models, it can run without touching any cloud service. And therefore, there's no cost involved to you. You can run these entirely for free. So that is my little demo of N8N. Let me know in the comments what you thought of this. You can see that we didn't rename that one to Live Demo 3. Let's just do that, just so we know which one we were looking at there. So we looked at, the first one was simply just getting some temperature values from our MQTT. So it's nice and simple, and then putting that into a table. We can have a look at what's gone on to that table so far. Let's go back to our data table, go into our live temperatures, and you can see there we've got 33 pages worth of data, 650 responses. We could feed that into an AI agent and say, is the temperature going up, is it stable, or is it falling? We could ask it to look at that and tell us if there's any anomalies in there. Is our sensor working correctly? So it can parse all that data for us. We then looked at how to build a server monitoring tool. So this will do IP address pings, it will do HTTP endpoints with a health check endpoint. It'll put all that into a spreadsheet, into a log, and it will also email us if any of those servers are down, so we can make sure that we get an email. And I've actually switched on my, I'll call it demo, these are actually live, it's the exact same workflow that we built out there. I've even put a little post-it note. You can grab post-it notes and you can even choose what colour you want the post-it note to be, for example. And this is just markdown. You can just type whatever you like in there and have these little post-it notes on your workflows as well. And then you can click on the tidy up. You can get it to zoom to fit. So if you've zoomed into a particular thing, you can just click on that zoom to fit and it'll zoom back. You can click on tidy up to tidy up all the nodes if they're all over the place. If you've been moving things about, you can click on that and it'll tidy them up. And we always need to be able to save our projects. If you want to have a large language model create one of these workflows for you, you can do that. And you just go to this 3 dots here and import from a file. So I think I created one of these previously. If I go to my downloads folder and I go into, there you go, server health monitoring, that looks very familiar. Because these are just JSON files. We can also download them if we wish, and that's now been downloaded. If we open that up, you just see it's a whole JSON structure with all the different nodes and settings for each of those. So very simple to get them in and out. If you want to go to like workflow history, you need to have selected that free license that was provided at the very beginning. Otherwise, I think that one is disabled as an option. And yes, you can look at all the executions. This is how many times it's been run, that each workflow. And there's even evaluations, which is how you can test this over different inputs. This is another, I'm not sure if this is paid for or if this is just an extra piece of functionality I've not looked at yet. But there you go. Definitely check out N8N. It's completely free. It runs on a Raspberry Pi. It runs on any platform, Windows or Mac, Linux. And yes, you can do really cool things with Agentic AI and have that a part of your home lab setup. Cool. Let me jump back to our slides. So that's my demo of N8N. If you want to check out our Discord server, we've got a really great community of people on Discord, all working on robotics projects, sharing their home labs, showing pictures of their pets and things. So if you go to kevsrobots.com/discord, you can get a free sign up link for that and join the community today. And if you want to follow me on social media, I'm on all the social media platforms. You can see there I'm on Threads at KevMcAleer, threads.net. I'm on TikTok at KevMcAleer6. I'm on Instagram at KevMcAleer. I'm on Threads at KevsMac. On Mastodon at kevsmac at mastodon.social, and I'm also on Blue Sky at kevsmac.bsky.social as well. So if you're on any of those platforms, give me a shout, say hi, share a picture of what you're working on. And if you want to get your name in the end credits, you can do that by going to kevsrobots.com/coffee. You can do a super chat, super thanks, buy me a coffee, either as a one-off or as a regular thing. You can do all the things. So a question there from John Wilson. He says, how long are the auth creds for Google Docs saved for? Do you need to re-authenticate every few days, weeks? I think that's down to the authentication. So it's down to Google or whoever you're authenticating with. A lot of the time you can set it to like 6 months or never, which is terrible. You should never have non-expiring credentials. But yeah, usually it's on the Google side. Essentially you go to is it api.google.com, something like that. So there's like a developer dashboard and you can create, if you click on the link from N8N, it'll actually point you to the exact path and give you the exact steps you need to take. Only takes a couple of seconds and it's very straightforward. Could you get your AI agent to do this for you? You absolutely could. You could get your N8N agent to build you an N8N workflow. So it's quite well known. A lot of and with it being JavaScript based, it's code. It's very easy for this to sort of pump them out. So yes, so if you want to get your name on any of these, you can go to kevsrobots.com/coffee, and I want to give a shout out to people who've done exactly that. So here we have on the left hand side here, Marie Louise Mayer bought me 3 coffees. Thank you very much for that. I do appreciate that. Sorry about all the YouTube adverts that have been interrupting your video. Do apologise for that, but that's what pays for the channel. Martin bought me 3 coffees and Charles bought me 3 coffees as well. So thank you all for that. And then on the membership side, on the Buy Me a Coffee, we've got Pietro, we've got Michael, Warren, Anonymous, Silicon Fiber, Marie TKD, Jeff, DN Corti, Marlene, and Tom. And then on the YouTube side, we've got Grandpa Gray, Shrishiva, we have Marie Mayer, we have Pete, we've got Dale from Hybrid Robotics, Oxrad39, Warren, Pierre Eves, Bert, Michael, Steve, Ford, Bello, Johnny, Stephen, John Paul, Cassie, Johnny Bates, and of course we have Tom. So thank you all for supporting the channel. It means so much to me that you do that. If you've not subscribed to the channel already, definitely give me a subscribe. That bit is completely free. Cool, so let's have a look. The spinny logo tells me it's at this point in the video where YouTube will be recommending over here another video for you to watch. Definitely check that one out. It's been handpicked by the algorithm just for you, and I'm sure you'll enjoy it. And so at this point in the video, I'll say thank you so much for watching, and I shall see you next time. Bye for now.